All right, welcome to section 2 of chapter 2, basic differentiation rules and rates of change. We're going to start off with the constant rule. The derivative of a constant function is 0. So if c is a real number, then the derivative with respect to x of c equals 0. Because a derivative gives us the slope, and the slope of a horizontal line, which is a constant function, is always 0. So let's find the derivative of each of these functions. The derivative of y equals 7, we could call it y prime, equals 0. If f of x equals 0, the derivative, f prime of x, is also 0. S of t equals negative 3, the derivative, s prime of t, equals 0. And the derivative of y equals k pi squared, let's call it dy dx, it's still 0 because that is all just a constant. Now, without any shortcuts, you're going to be asked to find each of these derivatives and look for any patterns you see. Remember that without a shortcut, the derivative of x is equal to, the derivative of f of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. To do this, you'll use the tricks that we learned in lesson 1. To save time, I'm not going to do all of these for you, but the derivative of f of x equals x is just 1. And when we do all the math, the derivative of f of x equals x squared is 2x. And for part C, this derivative will give us 3x squared. Part D, our derivative is 4x cubed. Part E, our derivative will be f prime of x equals 1/2 x to the negative 1/2 power. And for part F, our derivative is negative x to the negative 2nd power. Looking at all of those, hopefully you caught on to some patterns. The patterns form the power rule, and this one is very important, hence all the stars. If n is a rational number, then the function f of x equals x to the n power is differentiable, and the derivative of x to the n power equals n times x to the n minus 1 power. We take the exponent, bring it down out front, and subtract 1 from the exponent. For f to be differentiable at x equals 0, n must be a number such that x to the n minus 1 power is defined on an interval containing 0. Basically, if I end up with an x in my denominator, it's not differentiable there. So let's use the power rule. F of x equals x to the 3rd power. To get the derivative, we take the exponent, bring it down out front. So f prime of x, we get 3. Our x is still there, but we subtract 1 from the exponent, making it 3x squared. For part B, g of x equals the cube root of x, it's better to rewrite this as an exponent. The cube root is the 1/3 power. So to get our derivative, we take the power and we move it down out front. So g prime of x equals 1/3 times x, and we subtract 1 from the exponent. Remember here we're taking 1/3 minus 1, which is really 1/3 minus 3/3, which is a power of negative 2/3. A lot of times we won't want to leave a negative exponent. If a negative exponent is okay, this answer is perfect. But otherwise, we want to take a negative exponent and move it to the denominator. So g prime of x is actually 1 over 3x to the positive 2/3 power. And then y equals 1 over x squared. To help us out, we're going to write this with a power. It's just x to the negative 2nd power. So our power rule says we take that power down and out front. So dy dx equals negative 2x, and then we subtract 1 from the power, making it negative 3. We don't want negative exponents though, so we'll drop it into the denominator. The 2 is still in the numerator, so negative 2 over x to the positive 3rd power. Some steps to your differentiation problems. Step 1 is what you're given. Step 2 is to rewrite it. That's what we rewrote it as, x to the negative 2nd power. Step 3 is to differentiate, bring down the power, subtract 1 from the exponent, And step 4 is to simplify and rewrite it without any negative exponents. So let's find the slope of f of x equals x to the 4th power when a is negative 1 and when x is negative 1 and when x is 0. First thing I would do is find the derivative, because the derivative gives us the slope. So let's find f prime of x. Well, I can use the power rule to take my power out front and subtract 1 from the exponent. The derivative is 4x cubed. So for part A, when x is negative 1, all I have to do is take f prime of negative 1. I have 4 times negative 1 cubed, which is negative 4. The slope of this function when x is negative 1 is negative 4. For part B, we do the same thing. F prime of 0 is 4 times 0 cubed, which is just 0. When x is 0, the slope of the function is 0. I also actually want to take a moment to talk about your calculator, because in your calculator you can do this very, very easily. So on your calculator, you're going to hit math, and in math you'll see this n-deriv option, number 8. You choose that. Then you type this in, ddx, derivative with respect to x. Then we type in our function, which was x to the 4th power. And then we go over to x equals, well, if x equals negative 1, type that in, and look at that, negative 4. My calculator says negative 4.000004, which is basically negative 4. Your calculator does some even more complex calculations. The answer is actually negative 4. Your calculator is really, really close. So actually, let's do that again. So we hit math. Option 8 is n-deriv. You type in x for ddx. You type in your function, which again is x to the 4th power. And then we want x is 0. Press enter, and look at that, our answer is 0. This will not take and find the general derivative, which is this part right here. Your calculator won't do that for you. You have to do that by hand. Let's find an equation of the tangent line to f of x equals x squared when x equals negative 2. A tangent line means that we find the derivative and use that to get the slope. So the derivative of f of x equals x squared is 2x, because we bring down the 2 and subtract 1, leaving us just an exponent of 1. So I want to know what f prime of 2, or negative 2, is. Well, that's going to be negative 4 when I plug it in. To find the equation of the tangent line, I'll also need f of negative 2. Back to the original function, negative 2 squared is positive 4. So that means I want the equation of a line that goes through the point negative 2, 4. Okay, that comes from right there, with a slope of negative 4. That comes from right there. The derivative gives you the slope, the actual function gives you the point. So now we go back to point-slope form. Y minus y1, which is 4, equals your slope, which is negative 4, times x minus x1, which is negative 2, so plus 2. Distribute my negative 4, y minus 4 equals negative 4x minus 8. Add the 4 over. I get y equals negative 4x minus 4. There's the equation of my tangent line. Now let's talk about something called the constant multiple rule. If f is a differentiable function and c is a real number, then c times f is also differentiable, and the derivative of c times f of x equals c times the derivative f prime of x. Let's look at that in action. So if I want the derivative of y equals 5x cubed, I can take y prime equals 5 times the derivative of x cubed. Then I use the power rule. So I have 5 times, I bring down the 3, x, I subtract 1 from the power. So really the derivative is 15x squared. That's my answer. Y equals 2 over x. Well, the derivative, y prime, will be equal to 2 times the derivative of x to the negative 1st power. because I would have rewritten this as y equals 2x to the negative first power. So I keep my 2. I bring down my power, negative 1, x to the negative second power because I subtract. Combine terms and things like that, we get y prime equals negative 2 over x squared. For part C, f of t equals 4t squared over 5. We can do f prime of t equals 4/5 times the derivative with respect to t this time of t squared. We keep our 4/5 out front, we bring down the 2 and subtract 1 from the power, and then we recombine things. So I get the derivative of f of t equals 8/5 t to the first power, or 8t over 5. For part D, 2 square root of x, I would want to rewrite that as 2 times x to the 1/2 power. So my derivative, y prime, will be equal to 2 times the derivative with respect to x of x to the 1/2 power. So I get 2 times 1/2 x to the negative 1/2 power. Well, the 2 times the 1/2 cancels each other out. I get y prime equals 1 over x to the 1/2 power. Or a 1/2 power, remember, is a square root. So it is 1 over the square root of x. Remember that you do not have to rationalize the denominator when it has an x inside the square root. And letter E here, 1 over 2 times the cube root of x squared. Well, let's actually rewrite that equation first. We'll take our 1/2 out. We have x to a power of 2 over 3, but it's in the denominator, so it's negative. So y prime equals 1/2 times the derivative with respect to x of x to the negative 2/3 power. So I have 1/2 times, bring down my exponent, which is negative 2/3, and subtract 1 from my exponent, which makes it negative 5/3. Then I simplify. 1/2 times negative 2/3 is negative 1/3. And negative 1/3. I can put my x in the denominator since the exponent's negative. 5/3 power. You could also rewrite this as negative 1 over 3 cube root of x to the 5th power, whichever way you prefer. And finally, y equals negative 3x over 2. Our derivative will be negative 3 over 2 times the derivative with respect to x of just x. So we have negative 3 over 2 times, we bring down the exponent, which was a 1, and then we subtract 1 from our exponent, which becomes 0. Remember, anything to the 0 power is 1. So really I have negative 3/2 times 1 times 1, which means my derivative is just negative 3/2. We can combine the constant multiple rule and the power rule, so I didn't always have to do those in separate steps. We can just take our constant times the power times x to the power minus 1. So in this case, y equals 5 over 2x cubed. I would rewrite this as y equals 5/2 x to the negative 3rd power. But then for my derivative, I can really just go straight to multiply the negative 3 down, which makes negative 15 over 2 x to the negative 4th power, and then rewrite it negative 15 over 2x to the 4th power. For this one, we have a challenge because we have to actually cube the denominator. So y is 5 over 8x cubed, which can be rewritten as 5/8 times x to the negative 3rd power. I bring down my power for the derivative, y prime equals negative 15 over 8x to the negative 4th power. When I rewrite that, I get negative 15 over 8x to the 4th power. Y equals 7 over 3x to the negative 2nd power. Rewrite this function originally, 7/3 x to the positive 2nd power, because a negative exponent in the denominator bumps it to the top. And then y prime equals, multiply that 2 down, I get 14/3 x to the positive 1st power. No rewriting necessary. And for y equals 7 over 3x to the negative second power, I would actually bump this whole thing up to the numerator first. Y equals 7 times 3x to the positive second power. Because then I could say 7 times 9x squared, and I can say that it is 63x squared. Now when I take my derivative, I multiply the 2 out front, so I get 126x, and I subtract 1 from the power, so it stays just x. Now we have some sum and difference rules. This should come as no surprise. The sum or difference of two differentiable functions, f and g, is itself differentiable. Moreover, the derivative of f plus g, or f minus g, is the sum, or difference, of the derivatives of f and g. Meaning that if I have some function where terms are added together, I can take their derivatives separately and just add them together. Same thing with subtraction. I take the derivatives separately and just subtract them. So for f of x equals x cubed minus 4x plus 5. We have just some terms added and subtracted. So I can take each derivative separately. So to get the derivative, I'll take the derivative with respect to x of x cubed minus the derivative with respect to x of 4x plus the derivative with respect to x of 5. Well, the derivative with respect to x of x cubed is 3x squared. The derivative with respect to x of 4x is just 4, so minus 4. And the derivative with respect to x of 5 is 0. We could put a plus 0 on the end, but we don't really need it. So our derivative is just 3x squared minus 4. For part B, we're going to do the same thing. G prime of x equals the derivative with respect to x of negative x to the fourth power over 4 plus the derivative with respect to x of 3x cubed minus the derivative with respect to x of 2x. So now I'll find my actual derivatives. I bring down my power and the 4's end up canceling, so I have negative x to the third power because I subtract 1 from my exponent. The derivative of 3x cubed is going to be plus 9x squared because I multiply by the 3 and then subtract 1 from my power, minus the derivative of 2x is just 2 because I multiply by 1 and subtract 1 from my power. There's my derivative. Done. And then part C is a little trickier. We need to rewrite this one first, because I can take and figure out each of these individual fractions. 3x squared over x is 3x. Minus x over x is minus 1. And plus 1 over x is plus x to the negative first power. Now I can find my derivative, y prime, by taking the derivative with respect to x of 3x minus the derivative with respect to x of 1 plus the derivative with respect to x of x to the negative first power. So the derivative with respect to x of 3x is 3, minus the derivative with respect to x of 1 is 0, plus the derivative with respect to x of x to the negative first power. Bring down my exponent, x, and subtract 1 from the exponent. So when I rewrite this a little neater, I'll get y prime equals 3 minus 1 over x squared. And there is my derivative. And we're also going to talk today about the derivative of sine and cosine. The derivative of the sine of x is cosine of x. The derivative of cosine of x is negative sine of x. So just be careful, when you take the derivative of cosine, you get a negative in the front. So the derivative with respect to x of 2 sine of x. Well, I know I can just do 2 times the derivative of sine of x. So dy dx equals 2. The derivative of sine of x is cosine of x. So there's my derivative. Y equals the sine of x over 2. Well, that's really the same as multiplying by a half. So just like the last one, my derivative with respect to x is 1/2 times the derivative of sine of x, which is cosine of x. You could also write this as cosine of x over 2. For part C, y plus the cosine of x, the derivative with respect to x, so dy dx, equals the derivative of x, which is just 1, plus the derivative of cosine of x, which is negative sine of x. So I can really just say 1 minus sine of x. And then part D, the derivative of y with respect to x. The derivative of cosine of x is negative sine of x minus pi over 3 times the derivative of sine of x is cosine of x. And there's my derivative. Then we also have to talk today about rates of change. The position function is a function s that gives the position relative to the origin of an object as a function of time t. And the average velocity of this object is the change in distance divided by the change in time. So delta s over delta t. Change in position, change in time. So let's talk about this billiard ball. A billiard ball is dropped from a height of 100 feet. The ball's height, s, at time t is the position function s equals negative 16t squared plus 100, where s is measured in feet and t is measured in seconds. Find the average velocity over each time interval. For average velocity, remember we find s of 1 and s of 2. So I grab my calculator. S of 1 is 84, and s of 2 is 36. Now to find the average velocity, I'll go VF. We just find the slope between the points 1, 84, and 2, 36. So I take 36 minus 84 over 2 minus 1, which gives me an average velocity of negative 48 feet per second. For part B, well, I already know S of 1 is 84, and I use my calculator quickly to find S of 1.5, which is 64. So now I find my average velocity by taking 64 minus 84 over 1.5 minus 1, which gives me an average velocity of negative 40 feet per second. And same thing for part C here. I need S of 1, which I still know is 84, and S of 1.1, which is 80.64. So my average velocity is going to be 80.64 minus 84 over 1.1 minus 1. My average velocity is about negative 33.6 feet per second. But what if I want to find the actual velocity at 1 second? The velocity function is the derivative of the position function. So v of t is equal to my crazy limit definition, but it's just s prime of t. And then speed is the absolute value of velocity. So the absolute value of velocity is your speed function. Please don't use s for your speed function because the position function is always s. And then we have the position function. Position function is always the same. S of t equals 1/2 times g. G is the acceleration due to gravity, and g is a constant that depends on feet or meters. So if you're in feet, g is negative 32. If we're in meters, g is negative 9.8, which means in front of the t squared, you'll either have negative 16 when you multiply by half, or negative 4.9 when we multiply by half. Plus v of 0 t. V sub 0 is the initial velocity of the object, and then you add s sub 0, which is the initial height of the object. So at time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water. That is your s of 0, your initial, or s sub 0, sorry, your initial height. Because the initial velocity is 16, that's your v sub 0, and we're in feet, so that means g was negative 32. Our position function is negative 16t squared plus 16t plus 32, where s is measured in feet and t is measured in seconds. When does the diver hit the water? Well, this is not a calculus question. The diver hits the water when s of t equals 0. That's when negative 16t squared plus 16t plus 32 equals 0. Now's a good chance for us to practice our factoring. Let's take out our GCF, which is negative 16. Leaves me t squared minus t minus 2. Then when I factor, I get t minus 2 times t plus 1. So my answers are t equals 2 or t equals negative 1. Well, the diver only hits the water one time because this is the real world. And it can't hit it at a negative time. So the diver hits the water at time 2 seconds. The diver's velocity at impact. Well, we need the velocity function, v of t. And v of t is the derivative of the position function. So we use our constant rule, bring down the 2, so that makes negative 32t plus 16 plus 0. But I want it at impact, which is when t equals 2. So I want v of 2, which is negative 32 times 2 plus 16, which is negative 64 plus 16, which gives me negative 48 feet per second at impact.